Hello, mathematicians. This is Mr. DiAgostino. Unit 5, Lesson 3, Summation Notation. Here's a nice do now problem. Pause the video, do it before I go over it. The formula below can be used to model which scenario? A of 1 is equal to 3,000, A of n is equal to 0.80, A of n minus 1. Now that n minus 1, let's get a nice pen here. That A of n minus 1, that means the previous term. So you got to substitute in 3,000, get an answer. And if I want the third term, use the second term, plug it in, and get the third term. Now what I did was I did that for you. Okay, so let's take a look what I did. Hopefully that's what you did and try to figure this out. So I plugged in 3,000 because that was the first term. If I want the second term, I plugged 3,000 in, multiplied it by 0.8. Now remember what happens when you multiply by a number between 0 and 1. You get a smaller number. That's what you get, 2,400. Now if I want the third term of the sequence, I'm going to plug 2,400 in and get 1920. So that's, you can keep on going and generate as many terms of the sequence as you want. This is called a geometric sequence, could be because you're multiplying by a number to get to the next number. Now the only choice that's going to make sense, okay, if you want to pause and try to go through it again, you can do that, pause it. And the answer is choice 4. Okay? Answer is choice 4. Let's see why the answer is choice 4. This one's talking about more seats, which obviously it's getting less. Now this is saying 80 fewer seats, which it's 600 fewer seats with the first and second. Now, if you put money in a bank, 80% is a lot of money. And it's not going up, it's going down. And this makes sense because it's saying 20% less. 20% of 3,000 is 600. And as you can tell from 3,000 to 2,400, that's 600. 600 fewer. And if you continue, you'll get as many terms of the sequence as you want. All right, so today we're going to be doing summation notation. And summation notation uses the Greek symbol sigma. As you can tell right here, this is the Greek symbol sigma. Looks like an E. You're going to have an upper limit. Okay, you're going to have an upper limit. The N represents the upper limit. And the A represents the lower limit. Now with the sigma notation, this is a lower limit. So the lower limit basically is where you're going to start, and the upper limit is where you're going to end. Now what you're going to do is you're going to plug in. So say for instance your summation notation looks like this. I is equal to 1, and your upper limit is, say, 5. Your index is the variable that's going to be in the problem. So you can use I, you can use K, you can use J, you can use any variable you want. Usually I, J, and K are the standards. Now in the problem, you'll have some sort of expression, say 2I plus 1. What this is saying is you plug 1 in, evaluate, plug 2 in, evaluate, plug 3 in, evaluate, plug 4 in, evaluate, plug 5 in, evaluate, and then take all those and add them together. That's what summation notation means. You're going to evaluate each term, each individually, and at the end, you're going to add them together. So upper limit is where you stop, lower limit is where you start to plug in, and it goes by ones. 1, 2, 3, 4, 5, up to the upper limit. I is just a variable that you're going to be working with in the problem. You can use J, K, maybe X. Usually X is reserved for other things. So you don't really want to use X, but you can if you want to. All right, let's take a look at exercise 1. Again, what this is saying is you have a lower limit of 3, upper limit of 5, and here's your expression that you want to evaluate. Now you're going to evaluate it for 3, for 4, and for 5. And then what you're going to do is you're going to take all 3 of those and add them together. So let's see what I did for this problem. I plugged 3 in because that's where I'm starting. I'm plugging 3 in and evaluating that. 3 times 2 is 6. Then I do the next consecutive integer, which is 4, plugging 4 in. 4 times 2 is 8. Then the next consecutive integer after that is 5. So I'm going to plug that in. It gives you 10. Now when I'm done, I'm going to add all those together. 6 plus 8 is 14. Excuse me. Plus 10 is 24. So my final answer is 24. Let's see what's happening with B. I'm going to start with -1, plug that in, get an answer. Then I'm going to plug 0 in, which is the next consecutive integer. Then I'm going to plug 1 in, plug 2, plug 3. And then you're going to get terms that you're going to add together at the end. So again, you can always pause the video to see if you can do it before I give you the answer. So let's see what I did here. I plugged -1 because that's what I'm starting with. I square it. Gives you 1. -1 squared is 1. Then I'm going to put the next consecutive integer, which is 0. Square it. Gives you 0. Next one is 1 squared is 1, 2 squared is 4, and 3 squared is 9. Add those together. That's 13, 14, 15. So my final answer is going to be 15. Now again, like I was saying, if you can always pause the video, see if you can do it on your own before I go over it. Now C, you start with 2. That's your expression, 2 to the j. So you're going to plug -2 in. Then you're going to put -1 in. 0, 1, 2. You stop at 2. Now can you work with decimals? I just work with fractions just so you can see it. So 2 to the -2, because that's what you start with, gives you 1/4. 2 to the -1 is 1/2. And to the 0 power is 1. 2 to the first is 2. 2 to the second is 4. So I just kept on going until I stopped and hit my upper limit. Add these together. 1/4 and 1/2 is 3/4, or 0.75. And then 1 plus 2 plus 4 is 7. This is really 7 3/4, or 7.75. Again, pause it and see if you can do these on your own before I go over them. Now D is saying you're going to start with 1. You're going to plug 1 in. For the wherever you see that index, wherever you see that variable, that's what you're going to substitute it in for. Now sometimes there might be more than one variable in the problem. Here you just see I, or you might see I a couple of times. Okay, so you just, depending on the problem, you just substitute wherever you see the variable. So in this case, I. Wherever you see an I, you're going to put a 1. So you only see I once. So you just put it in once. So -1 to the first is -1. Then you go to the next consecutive number, which is 2. -1 to the second is +1. Then you do -1 to the third, which is -1. -1 to the fourth, -1 to the fifth. Evaluate that. When you add them all together, -1 plus 1 is 0, -1 plus 1 is 0, and then you're left with a -1. So your final answer is -1. All right, this one is actually pretty easy. You put 0 in for k. 2 times 0 plus 1. All right, 2 times 0 is 0 plus 1 is 1. Then you're going to put 1 in. You get 3, and then you put 2 in. You get 5. So again, you're going to evaluate each one separately, and at the end, add them together. So your final answer is going to be 9 for that one. All right, now this is what I was just talking about before, about when sometimes you might see 2 i's in the problem. So that means you're going to start with 1. You're going to put 1 wherever you see an I. Then you're going to put 2 in. Then you're going to put 3 in. Then you're going to add those all together. So let's see what we get. 1 times 1 plus 1. So 1 plus 1 is 2. 2 times 1 is 2. Then you're going to put 2 in wherever you see an I. 2 plus 1 is 3. 3 times 2 is 6. And then you're going to put a 3 in wherever you see an I. 3 plus 1 is 4. 4 times 3 is 12. Add those together, and you get 20. All right, so summation notation, basically what that's doing is it's having you start with a lower limit, put it in, then you do the next consecutive number, put it in, evaluate each one individually, and at the end, add them all together. Now, remind me tomorrow in class to show you how to do this on the calculator, because you can do this on the calculator. But I'm just showing you right now how to do it by hand. Exercise 2. Which of the following represents the value? So we have sigma notation. So we have a lower limit of 1, upper limit of 4. So now you're going to put 1 in, you're going to put 2 in, you're going to put 3 in, you're going to put 4 in, you're going to stop, add them all together, and see which one you get. Now, it's a multiple choice question, so you can use, you can leave it as a decimal, and then at the end, you can just evaluate each of the choices and see which one is the same decimal as what you have. So let's see what I have. So I put 1 in, got 1 over 1, which is 1. Then I put 2 in, got 1 over 2. Then I put 3 in, got 1 over 3. Put 4 in, got 1 over 4. Now, if you want to add fractions, you have to get a common denominator. So the denominator is a 12, and you get 25 over 12 when you add. You can also use a calculator if you want. You're going to get a decimal approximation. If you have one of the graphing calculators that the school provides, you can convert it back to a fraction, okay, after you get the decimal. So a couple of ways you can do it. All right, number 3, consider the sequence defined recursively by a of n is equal to a of n minus 1 plus 2 times a of n minus 2. Now, this means you need the 2 previous terms of the sequence. They give it to you. If I want the 3rd term of the sequence, you need the 2 previous terms, which they give you. So now what this is saying is you're going to start with the 4th term of the sequence, do the 5th term, the 6th term, and you're going to stop at the 7th term. So you need the 4th term, the 5th term, the 6th term, and the 7th term. Now, this is going to help you generate those terms. The recursive definition is going to help you. Again, pause it, see if you can generate up to the 7th term of the sequence. You should be able to do that at this point. All right, let me show you what I did. They gave us the 1st and the 2nd terms of the sequence, 0 and 1. Now, what this is saying is take the previous term, which is 1, add to the 2nd previous term, which is 0. Add those together, you get 1. Now, if I want the 4th term of the sequence, you take the 2 previous terms and you put into the formula. So you have 1, and then you take using the formula, you take 2 and you multiply it by the 2nd previous term. That gives you 3. Now, if I want to use the formula again to figure out the 5th term of the sequence, you put 3 in, add it to 2 times the 2nd previous term, which is 1 again. So 3 plus 2 times 1 is 5. Now, if I want the 6th term of the sequence, you take the previous term, which is 5, add it to 2 times the 2nd previous term, which is 3. So 5 plus 2 times 3 is going to be 11. Okay, 2 times 3 is 6. Add it to 5, gives you 11. Now, if I want the 7th term of the sequence, again, you need the previous 2 terms. Take 11, add it to 2 times the 2nd previous term, which is 5. Add those together, you get 21. Now, they want us to find the summation of the 4th term all the way up to the 7th term. So the 4th term is 3, 5th term is 5, 6th term is 11, and the 7th term is 21. Add those together, and you get 40. So the sum from the 4th term all the way up to the 7th term is 40. Exercise 5. Now they want us to go in reverse. Okay, I'm going to use my pen here. Some people, I'm getting used to this, so just bear with me. Writing's not the best, but I'm getting better at this. All right, so get my pen. I made some notes here, just when I first looked at it, this is some of the things that came to my mind. Okay, how do you get 9? How do you get 16? How do you get 25? How do you get to 100? And what this means is there's other terms in between these two. So, that being said, if I take a number and I square it and I get 9. So these reminded me of perfect squares. Now what will be the next one? What's 5 squared? 25, right? That works. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. And 10 squared equals 100. Now they want us to come up with a summation notation. We need an index. We'll call it I. Now, what's the first number that we're plugging in here to get 9? 3, right? And then we're squaring it. Let's go back, sorry. So we're taking a number I and we're squaring it. So the first number that we're plugging in is 3. So 3 squared is 9. Then you do the next consecutive number, which is 4, 5, 6. Where are we stopping? What was the last number that we squared? 10. So the upper limit is 10. Okay? So this would be your summation notation. And that would generate that sequence. Then you would add it all together. Now this is what I did with this one. With this one, I kind of tried to figure out what is it going by. Okay, it's going by, looks like it's going by 3s. And then I just kind of added the extra terms that were in here that were missing. So how many total terms are there? -6, -3. So it's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 terms. So my 8th term, when I plug it in, has to be 15. So let's see. We need the summation notation. We'll use it doesn't matter. So when I plug it in, I want a -6. That's the first thing I want to do. Now I know that's the first term of the sequence, and it's going by 3. So you remember the formula that we came up with? So my common difference is 3, and to figure out any term you want, it's always going to be one less amount of terms times how many 3s or how many common differences that we're going to add. And that's always going to add to the first term of the sequence. And now we said we had 8 terms, right? So we're going to start with 1 all the way up to 8. Let's see if this works. Let's put 1 in. 1 minus 1 is 0. 0 times 3 is 0. 0 plus -6 is -6, so that works. Let's put 2 in. 2 minus 1 is 1. 1 times 3 is 3. 3 plus -6 is -3. Let's see if I want the eighth term works. 8 minus 1 is 7. 7 times 3 is 21. 21 minus 6 is, or 21 plus -6 is 15, so that works. All right, next one. What I notice is that it's going from 1/25 to 1/5 to 1, 5, all the way up to 6/25. And there's a couple ways you can do this. You can try to come up with the formula to represent this, or if we rewrite it as 5 to the -2 plus 5 to the -1 plus 5 to the 0 plus 5 to the 1st. What do you notice about the numbers that you see here? They're all what? They're all 5. So when we do the summation notation, it's going to be 5 to the something. Let me give you a better summation notation. Again, I'm just working on this tablet. So I want a better summation notation, so I just rewrote it. Now I know it's going to be 5 to the something. Now what do you notice? It's going with -2, -1, consecutive. We start at -2. So if we start at -2, we'll use I. Now what do we go? So what's 5 to the what gives you 625? 5 to the 4th. So that's going to be our upper limit. So when we plug it in, 5 to the 4th is 625. 5 to the 3rd is 125. 5 to the 2nd is 25. 5 to the 1st is 5. So there you go. That's, I mean, like I was saying before, there's many ways you could have done this. You could have came up with the sequence, the formula to represent the sequence if you wanted to. But this might be an easier way to think of it as. All right, number 5. Which of the following represents the sum 3, 6, 12, 24, and 48? Now let's go through the choices. Since it's a multiple choice, let's go through the choices and see if we can eliminate a couple of choices. If we put 1 in, because this is telling us start with 1, plug it in. Do we get 1? Do we get 3? Yes, we do. 3 to the 1st is 3. Now if you put 2 in, do you get 6? 3 to the 2nd is not 6, it's 9. So that's gone. How about choice 3? If you put 1 in, 1 minus 1 is, sorry, you put 0 in because they're starting with 0. Put 0 in. 0 minus 1 is -1. 6 to the -1 power. What's that? That's actually 1/6. That's definitely not 3. Let's take a look at 4. If you put 3 in, you get 3. If you put 4 in, you get 4. You don't get 6. So using process elimination, the answer is 2. Let's see if it works. Put 0 in. 2 to the 0 is 1. 1 times 3 is 3. Put 1 in. 2 to the 1st is 2. 2 times 3 is 6. Let's put 2 in. 2 to the second is 4. 4 times 3 is 12, so that works out. Just use process elimination for that one. All right, last question. Exercise 6. Some sums are more interesting than others. Determine the value of. Now, tomorrow, like I said, if you just remind me, I'll show you how to use the calculator to answer that question. But what I just did, you're not going to sit there and put 1 in, put 2 in, put 3 in, put 4 in, put 5 in, put 6 in, put 7, all the way to 99. That's just crazy. So what you do is you see what the first one is. Okay? So you put 1 in, you get 1/2. Then I put 2 in, and you get 1/6. But if you notice, 1 minus 1/2 plus 1/2 minus 1/3. If you actually see it, there's a pattern here. See the pattern? Also, you notice 1/2, 1/6 is 1/12. It's getting, when you add these together, it's definitely going to get close to a certain number. But if you look at the pattern here, 1, negative 1/2. And if you add, because you're adding these all together, negative 1/2 plus 1/2 cancels out. Negative 1/3 and 1/3 cancels out. If you keep on going, there's a pattern. All the fractions are going to cancel out except for the first one, okay, which is 1. And the last one. What's the last one going to be? 1 over, what's 99 plus 1? 100. So what's going to be left is 1 and the last term, which is 1 over 100. Now, if you subtract that, 100 over 100 minus 1 over 100 is 99 over 100. All right, this is called the telescoping series. It's going to get close to 1. It's not going to get to 1. It's going to try to get to 1. It's going to try to get as close as possible to 1. 99 over 100 is pretty close. That's 0.99. Now, if you change this to 999 and 1, you're going to see that the answer is going to be 999 over 100. I'm sorry, 999 over 1,000. So you're going to notice that it's trying to get to 1, but it never gets to 1. So all the fractions can cancel except for the first term and the last term. So when you subtract that, you get 99 over 100. All right, good lesson. Hopefully everybody watched it. You guys are definitely truly mathematicians. I want everybody to feel that way. I want you guys to feel like you guys can do the work. And by working in groups and having me in class to walk around and facilitate, it definitely makes everything better. All right, good job today.